again, another break and time for exhibit hall, and then we have an amazing closing keynote for you. So to start things off, I want to introduce our opening keynote speaker, Daniel Granger. He is the lead engineer at Speed UTV and Robbie Gordon Motorsports, and he's going to talk to you about how the real life experience that he had as a student put him into the career he is in today. So Daniel, if you wouldn't mind joining me on screen.
Hey, thanks a lot, Sarah. Thank you for inviting us to speak about my experience and my story and getting here. And hopefully I can inspire some similar stories for the next generation.
Perfect. I'll let you take it from here if you want to go ahead and share your screen.
Awesome. Let that load. So, hey everyone, my name is Daniel Granger, and I was going to talk to you tonight about my real world engineering experience and how that's led me to where I am today. So first off, a little bit about me. As I mentioned, my name's Daniel, and I've got a Bachelor of Applied Science in Mechanical Engineering. And my current occupation is design engineer in off-road racing and power sports industry. So I'll give you a little bit of an outline of what I want to touch on today, which is just about me and my role as a Baja SAE captain at my university, and then now as a lead engineer for Speed UTV. And I want to focus a lot on what Baja SAE is and how the events and the design process students go through help develop the skills that get them ready for real world careers. And then I'll give you a little bit of a build breakdown on some of the cars that I've been involved with and off-road vehicles. And then we'll touch a little bit on some of that technology and the design process and how it's not always what you see in a textbook that works in the real world, and how you can achieve a good design in the real world through valuable testing and experience. And then, of course, just outreach and inspiring the next generation, whether it's industry through college students and design teams, or design teams inspiring the next generation in high school. So, bit about me. I attended the University of British Columbia from 2013 to 2019, and for all of my years there, I was involved as a member on UBC Baja, which is a collegiate engineering design team. So I joined Baja my first year as a rookie. I was interested in cars and trucks and off-road and suspension, and just took on some small projects in my first year. Just the little fixture for manufacturing the arms and some pretty basic strength analysis. And then by the time I was in my final year, I was able to really grow with the team and became responsible for overseeing all the technical goals for the full vehicle design, as well as managing and mentoring new team members and passing on the knowledge. And so that's an interesting thing with these collegiate level teams. You have essentially 100% turnover rate every 4 or 5 years. So that was one thing that we really focused on, was trying to build the legacy and ensure the next generation had a better spot to start from than did. So this is me throughout my years of the Baja SAE competitions. From 2015 in Oregon, just a little baby face there and kind of a little bit of a beat up rugged car. And hopefully you can see as the years progressed, so did the car. We ended up with some nice billet suspension components and a really well performing team and car. So then I graduated in 2019 with my specialization in mechanical engineering, and that landed me my dream job, working for this guy over here.
Be careful what you wish for.
Robbie, who's over my shoulder here all the time, and we are now deep in the process of designing the Speed UTV, and we are really just days away now from flipping the switch on full production. And this is essentially what I hopped into.
Hi, everyone.
Details done, and these are just test parts. So production has started, and there is a lot of production parts out there. I don't know if you guys have joined in and seen some of this stuff, but here's a look inside the gearbox. This is our torque limiter here with some dogs on the torque limiter down inside the front. That's the front bulkhead. It is not solid, it is definitely hollow inside. Nice beefy tabs. We have done all kinds of durability testing on these. Have smoked the tires off on this car. And walk around over here and give you a little So take you back through the tools again. Probably like to see the spark plugs in this thing. Daniel, we out of business? No. No voice, huh? Dang, you have a hell of a presentation put together. Very proud of what you put together there. And I hope everybody can see it. I know that my Instagram here, I'll flick through it, show everybody what's going on a little bit. This was testing out of Glamis not too long ago. It's a way of sending it off into the sunset there. So the stuff that Daniel has designed has been very cool, been a lot of fun. And they can see your screen, but no voice, huh? Do you want to try to go off Wi-Fi, and can you link to your phone, maybe?
Try.
We have struggled the last 60 days here with Wi-Fi, and even getting on to join some of our files here. Another wrap here. Rob Harris has been working on the wraps. We have pushed the trigger on the first 100 of these things, and more are coming out every day, but this one's pretty cool. It's got the carbon inlay back end, and then obviously the speed orange. 1, 2, 3, 4. Master numbers will be up on the number plate. So based on the car that you picked and what you got. Had to increase the mirror mount just a little bit to be able to see here without losing too much on this A-post support, but I feel this A-post support is very, very, very important. We are the first production UTV to enter the market with an A-post support bar, and as you see, it doesn't intrude anything into the driver's compartment. It goes right outside there. We do have our speed seat belt with the, this is the first for a cam lock system that has the governor speed if you don't have your seat belt on. So that is connected into the center point. Don't judge this this here. We cut it with a razor blade on purpose because I needed a wider hole to get this big buckle through, but it takes a lot more room to get through there. So we've already adjusted all the seats to accommodate this, but as you can see over there, just was a little too tight to get it through. We're able to get our smaller buckle through for the passenger, but we have a requirement through CARB EPA that we have to have this safety wire switch here. Flick it through the dash real quick.
Oh.
As you see, the D-shaped wheel allows you to see the 10-inch flat screen. With a regular steering wheel, you wouldn't get to see the screen.
Are we back now?
This car.
So sorry for technical difficulties, everyone. It looks like Daniel is back. If you want to go ahead and try to kick
These
back
are
up.
little segues to get around the factory.
Yeah. About that?
You got your phone now?
Nope. I'm back on the Wi-Fi. Hello, can everybody hear me? Hopefully. Sorry about that. I'm not sure where we left off, but I was just getting into what we do at our Charlotte, North Carolina headquarters for engineering. So we use exclusively SolidWorks for all our 3D modeling. Here's part of our engineering offices, and you can see we've got windows right out into the fab shop and the mechanics area. And so that's something that we feel very strongly about, is making sure the connection between engineering and the people who are doing the work, and oftentimes we do the work ourselves, but we try and maintain a close relationship with the fabricators, the mechanics, the machinists, and listen to them and take their input, and it makes for a better design, because at the end of the day, they're the experts who work hands-on with these parts that we're designing, and we can make a better product if we take that into consideration. And so part of the experience is also going out into the real world and testing. So this is a shot from Klamath sand dunes in California, where we often go out to the desert in California, Arizona, Nevada, Utah, and of course Baja, Mexico, to test out these vehicles, and that's where we learn a lot. And then this explains the Wi-Fi connection, but we are currently overseas at one of our manufacturing facilities. So you see here we've got rows and rows of CNC machines just churning through our cast and forged parts. And there's me standing in front of some big tools for injection molding plastic fenders. And it's just crazy, the scale of these massive chunks of steel that you don't want to mess up on when you're designing. But back to the main point of this talk, and what got me here is Baja SAE. And so Baja SAE is an annual engineering student design team competition, and it's hosted by the Society of Automotive Engineers, where students are tasked to design and build a single-seat off-road race car that conforms to a strict set of rules, and then compete against hundreds of other universities from around North America and the rest of the world. So here we are in 2018, I believe, down in California. That's the UBC team. And you can see it was a muddy year in California, which is very uncharacteristic of the desert out there. But we've got to try and build these cars to withstand all conditions. And so the competition itself is broken down into two main sections, with the static events and then the dynamic events. So the static events comprise of design presentation, a cost presentation, sales presentation, and then, although it's not scored, there's a technical inspection, which we take very seriously, because that's the attention to detail that sets your team apart from the rest. And very few teams make it through technical inspection on first try, but we were pretty proud that we were able to go through first try on many of our competition in the later years of my tenure with the team. And that translates into just overall better build quality of the vehicle and attention and the rules. And then as far as dynamic events go, there's an acceleration, maneuverability, suspension, and endurance event. So the design presentation is basically you take your designs in your car and present it to industry professionals. So there's people from Polaris, Honda, Magna, and some of these other off-road focused power sports companies, and they break it down into the different technical sections. So you're presenting to a very high technical level of professional experts in the industry, and they want to know why you designed a part a certain way, how you got there, and what did you do to validate that your design was actually correct. So it's not just as easy as saying, oh, we designed this part and it survives this kind of load case. You have to go and prove with data why that load case was selected. And then ideally you can prove that your part performed exactly to the level that you predicted it would. And so we use the tools built into SolidWorks with their finite element analysis, stress calculations, and you can see a couple screenshots here from a couple parts where we've done some analysis on those. And then the dynamic events are obviously the fun ones, but they consist of just a 100-foot acceleration, a maneuverability course, which is basically like a tight autocross course, but off-road, and then a suspension and traction course, which is what this photo up here is, and where they build some gnarly log drops and rock crawls and rock pits that are designed to push the vehicle to its limits. But the ultimate event is the 4-hour endurance race, where we race wheel to wheel with 100 other teams for 4 hours around a motocross style course, where they also build extra obstacles that really are designed to push and break these cars. And it's oftentimes less than half the field completes the race. And all these scores go into a competition score, and the best team wins. But realistically, the premise of these competitions are to help develop engineering students to become better engineers and prepare them for the workplace. So one of the biggest things is obviously the CAD skills. And so, you know, I started in my first year barely even knowing what 3D modeling was. And that's the case for a lot of students. And now there's more and more programs that are helping introduce 3D modeling at a younger and younger age, which I think is fantastic. And we even have Robbie's, 13-year-old son, Max, working in SolidWorks, designing parts at the shop. But just the sooner you can learn this language of 3D modeling and become proficient in it, it just helps. And so the student teams actually take it on themselves to teach CAD at a higher level than school curriculum often calls for. And, you know, we do this through our own internal team training sessions, of course, the built-in tutorials with SolidWorks, and then there's many programs online available that help teach certain tips and tricks. And then we've also done a few videos and procedures where if we have a unique problem or we make that video and then post it online and share it with other teams as well. So well, hopefully we haven't lost it again. I see my side screen went out, but I'll keep going through with the hopes that you can still hear me. But then, of course, the design process is an important factor in the entire process. And so we go through from setting the initial goals and constraints of the part to taking a first step and use your best intuition at shaping the part. And then we go through and use the tools like finite element analysis. Oh, we lost it. Uh-oh.
Zoom back in or log back in.
Yeah.
This is what it is. This is why we've haven't done the live stream updates while we've been here. It's very, very hard to get service. I'm surprised my Insta is going. I'm not on Wi-Fi. I'm just on cell service, but I did change my service plan a couple days ago, and that seems to be a little bit better. I'll do a little walk around for the ones that haven't been on, some of the parts and components that we have going on. Take you guys through the tools. This is the large case mixed with the UTV case, which gives us multiple wrenches and lots of metrics to choose from. The standard has a small amount of metrics, and then we come over here and this is a full case of metric tools. Look at that, it's like turned around the wrong way. I'll be disappointed.
Hi everyone.
That stuff
as you can all see, we're having some technical difficulty with Daniel. Because of timing and to keep everything on schedule for for the rest of the day, I'm going to go ahead and make the decision that we will record his session and we'll make sure to send it to everyone so that you can still benefit from everything he has to say, and you can learn how your schools can get involved. Daniel, it looks like you might be back. I maybe spoke too soon.
I'm so sorry about that. We're so spotty over here. It's our connection. Wi-Fi is not the greatest, but I'll try and power through in the last 4 minutes and at least let you take a look at all these slides. And I'd love to be able to answer any questions in the future.
If you want to power through real quick, and then let's make sure we can record this and we'll send it to everyone as well so that they get your full presentation.
Okay, great.
Cool. Yeah, I'll let you take it away again.
Okay, so here's just a kind of some iterations of the design process of setting the goals and constraints of the general shape, and then you take your stab at designing the part, and then you use these tools to help improve it. And you can see we've removed material where there's low stress and then changed the geometry where there's higher stress. And then the great thing about these teams is it allows you to take these into real life parts and then validate the design. So here's some examples of some of the parts we've built on the Baja SAE team in the past few years, with beautiful machined billet aluminum suspension components and uprights and fabricated lower control arms and sheet metal welding and machining parts. But then you also have all your hand skills. Just working hands-on and learning how things fit together really helps you understand tolerancing. And we have a saying at the shop that, well, it fits in the model, but might not fit in real life. So you need to take those skills and experience into consideration. And the sooner you can start understanding that, the more quickly your designing skills will reach a higher level. But then also business skills and teamwork and leadership. We essentially run these teams as a small business. We're supported through the school to some level of financial aid, and different schools vary. But it's on us to go out and find sponsors in the real world to fund us or sponsor their machining time to help these parts. So not only are we just designing, we're managing budgets and outreach and social media engagement. So it's really an all-around, real-world project. So here's some quick stats on the car. This one, it's crazy. They only give us 10 horsepower to work with, which maybe makes sense for students. But I know our team's suspension could have handled a little bit more power than that. But here we are now with the Speed UTV. What I'm working on is basically same kind of idea, but 10 times the horsepower, and I'd say, well, definitely more than 10 times the budget.
22 times.
22 times?
Or 30 times.
30 times. And then obviously the big dog is the Unicorn Trophy truck. Now this is the Formula One of off-road and really the highest level. And I'm fortunate enough that with Robbie, we work on all of it, from portals to shocks to tires to gearboxes, engines, complete chassis and suspension. I've had the opportunity of working on everything, and it's my time and experience with the Baja teams that allowed me this experience. Now, here's where the RWE comes into play. This arm, you can see in the computer simulation of finite element analysis, it survived. It's 3G loading scenario, can survive 3 times the car's weight, landing on one wheel, no problem. But on the other side, you see this arm is pretty mangled and definitely didn't survive. Now, what this was through the rock crawl event, we hit a rock and it nicked the structure and it all went to pieces. And now that's an example of it looks good in the computer, but you need to consider these other real world examples. Now, when Robbie saw that, his first thing was, do those survive? Because he did it for years. And so said those might be a nice sand arm, but they probably won't last any rocks. And so that's really the importance of testing and getting out into the real world, because you can spend years in your classroom, but until you get out in the real world and test, you can't prove that these parts will work. And we took that to heart with the design teams as well. you see us here, we're jumping down the set of stairs at the school. Now it was somewhat sanctioned. We did it safely, but it's it just shows, get out and test. You learn so much, and it helps make a better project and better experience, and that sets you up for a successful career. So at Speed UTV, almost all of our employees currently have come from a Baja SAE or a Formula SAE background. So here's a photo of Kyle and Jeff, who have both been on Baja, and Jeff is on Formula SAE at UBC. And we also have Jason with us right now, who's also been on both of those student teams. And, it is absolutely important what you learn in the classroom. That's where you learn your technical skills for doing calculations and analysis and understanding what these tools are telling you. But it's really the real world, practical, hands-on applications that help set, these individuals apart. And I feel lucky that my time on the Baja team has led me to this career. So as you can see here at the university level, we focus on outreach and inspiring the next generation, whether it's high school students or just taking the engineering students at the school and helping them, bring them up and give us, share with them our engineering experience that we have so far throughout our time on the team, and just passing on that knowledge. We also want to excite and inspire the younger generations, and it's really a fun and fulfilling way to do that. And I feel privileged that I've been able to be a part of that. And just some numbers to share with you how successful these teams can transfer into real world careers. So from my school alone, in the time where I was there, I know we have 3 alumni from the Formula SAE team working in Formula One, and we've got another 3 working here at Robbie Gordon Motorsports, which is the Formula One of off-road. And then there's countless more students that have this design team experience that end up and have successful careers at automotive companies like Tesla and Lucid, General Motors, and many more, especially even in the non-automotive sector. And these teams, even if you're not specifically interested in cars, we teach that entire design process. And that really having that practical experience outside the classroom. I know when I'm looking at resumes now, I don't look at marks, I don't look at grades, I just look for the projects and what project portfolio they've done. And I look at asking, what have you built? And really exciting. And I think that with technology now and the software, it's becoming more and more accessible at younger ages and more readily. And we see a lot of great young students who maybe didn't have any interest or any experience working with cars, and they're able to take those skills and learn with this team and learn leadership skills and design skills. And I really want to thank SolidWorks because they're a huge supporter of all these SAE programs and universities. So I believe almost any student, if they're interested, they can get the real deal SolidWorks. And it's a great technique by them, because once we graduate and come out to industry, we force these guys to buy SolidWorks, because that's what we want and that's what we use. And so if you know anyone who's interested in joining UBC Baja specifically, or another design team, encourage them to reach out and look online at the schools they're looking to go to. I know I definitely chose UBC because of the Baja team being there, but applications are available online. Many of these teams have social media. You can find out about UBC as Baja team at UBC Baja on Instagram, Facebook, YouTube, and the website is there as well. But I just want to say thank you. I apologize for the Wi-Fi interruptions. But you can check out more about Speed UTV, what we're doing at Speed UTV on Instagram, Facebook, and YouTube. I think we're live on there right now. But huge thank you to Solid Professor, SolidWorks, and Hawkridge for setting up this opportunity for me to share with you, and hopefully pass on some of my knowledge and experience to these educators so you can inspire the students that you interact with on a daily basis. So thank you very much. Apologize for the interruption, and I'll hand it back over.
Thank you, Daniel. And again, for everyone who is tuned in and experienced the technical difficulties, I'll work with Daniel to record his entire presentation, and we can send it out to everyone. Just so in case anybody missed part of it, they can get the full presentation and all the information. And I know a couple of you put some questions in the chat as well. I'll make sure to send those to Daniel so that we can answer those questions for you also. I do want to just quickly remind everyone that there are a couple tips for the platform in case you have any issues technically. It's best to close other tabs and programs. Chrome is Excelivant's preferred browser. Internet Explorer is actually not supported. So if you're on Internet Explorer, maybe switch. That could help. When in doubt, refresh. Usually that helps. And in the breakout sessions, we encourage you guys to ask lots of questions. Every breakout session has left time at the end to answer your questions, so they are intended to be interactive. And all the sessions are recorded, so you will be able to access these recordings for 30 days on Excelivant. And then if you're a Solid Professor member, you get access to them through your Solid Professor account forever. So one last reminder, go visit those booths. We got Autodesk, Onshape, SolidWorks, and Solid Professor booths. We are encouraging you to engage with them. So if you ask questions, if you download some of their handouts, you get entered to win these prizes. So we do have raffle prizes that'll be announced at the closing keynote. One of them is an Ember temperature-controlled travel mug, and the other one is a 4th generation Echo. So they're cool prizes. They're easy to win. Go engage with those sponsors, and we'll see you guys back for the breakout sessions at 10 a.m. Thanks.